I'm Jakub Klausa. I'm with SS7. As the name states, we mostly do work on SS7, but sometimes interesting projects like this come up, and we dive deep into that. So this is the short agenda of my presentation today. As coal mining is a pretty small, it's big industry, but pretty small on number of people involved. So not many people know what coal mine emergency system is. So I'm going to explain that. I'm going to explain how did it happen that asterisk was an option for this kind of systems. What were the prerequisites for the system, how it went, and all the other stuff. Of course, there will be a QA at the end. Funny fact, that's an outline of map of Poland. At the north end of the map, we have Baltic Sea, and at the south end, there are Carpathian Mountains where the coal mines are. The system I'm going to talk about today was the project was started by the company located at the farthest north part of the Poland, and they are building it for companies far up the south. So it's a fun fact if you live in Poland, the opposite side of the country. Okay, what's coal mine emergency system? In essence, it's a PBX with some fancy features. The fancy features are specialized queues for all kinds of emergency situations and priorities. Emergency system in coal mine requires calls to go through an operator, so there is no automatic connection of calls. Everything has to be done manually. That's the regulation in Poland. There is a requirement for paging and some kind of messaging because down there there is a rough situation down there. There is a lot of noise, a lot of moist. There is high humidity, and the temperatures in the coal mine shafts are really high. So talking is not always an option. So some other kind of communications is required. There is a requirement for fast phone failure detection because, the sooner you know something bad happened down there, the better. And they are using all kinds of indicators to see if something happens. So one of them is phone failure because phone lines are one of the only few installations that get carried down the corridors, down the shifts, there is requirements for recording, which is obvious as it is emergency system. There is a requirement for input from another, wide variety of inputs like methane detectors, shock detectors, and whatnot. And other features like RFID indicators or Bluetooth gates. I'll explain on that because the regulation about coal mines is that not too many workers can gather in one place. It has to be there has to be some kind of measurement or monitoring if they don't, because it would be very dangerous if too many people gathered in one place and there was some kind of accident. It would be not good perspective. Okay, so that's the short description of what emergency system in a coal mine situation is, and now why this all came to life. There was, of course, emergency system in the coal mine that was going to implement this one. But it consisted of an old PBX, which was nearly end of life, and there was a component shortage. There were no more cards to connect more phones and outside lines and stuff like that. No new technologies were implemented like the RFID or Bluetooth gates and stuff like that. It was based on a third-party product, so the upgrades were slow, and custom development was expensive and problematic. There was no upgrade path for the system. The vendor of the previous system didn't have anything to add to the system and didn't have really any upgrade path. And the system was limited. Beside the component shortage, the system just was about to reach its limits. So one of the most important prerequisites for a system like that, especially in a coal mine, is spark resistance of most of the elements because of the obvious methane that builds up down there. And it's a challenge because we live in an age where everything is smaller and smaller, getting more complicated, and it doesn't take this into account that some environments have requirements like that. So spark resistance was an issue. Of course, the new system was required to have all the capabilities and functionalities of the old one, because why bother to change anything when it's not for better? And coal mining in general is a very conservative industry. They don't want to change anything unless they have to. So this was one of the prerequisites. Okay, then per usual, the systems are vendor locked. I mean, vendors provide all the handsets, all the external detectors and stuff. And the company that was building this one was eager to support different vendors in case of the phones, of the handset, because they were, the Chinese products were used here and there, and they wanted to support that. Not to require that, but support that. Is the development of new features that it's obvious that they wanted that. Capacity greater than the previous system, that's of course always understandable. And modularity, they wanted to segment the system and leave a room for growth and for other services or anything. So the key element of the system from the user perspective is the phone. It doesn't look fancy for everyday use, but it's very useful construction for an environment it is going to be used to in. In fact, that's the only coal mine phone that has display, because of the power constraints. None of the other phones has this feature, which is obvious for most of us, but down there it's not so obvious. Of course, big keys and a big red alarm button. It's not cast iron. I would say it was, but it's not. It's very heavy and thick steel. So that's the interface the miners use in the shafts. And that's the old construction. If you take a look at the handset, it changed in the newest version because of the gloves, industrial gloves the coal miners used. It was impractical for them to use the handset of the previous generation, so it changed a little. The internals changed a little as well. But in general, that's the phone. It's very heavy, very big, and very useful down there. So the phones are connected to gateways, VoIP gateways based on Blackfin platform, which we used with the Syllab 3215 chip and changed to 3217, which is newer chip, more advanced, with both FXO and FXS capabilities, and simply more power. Of course, there is the asterisk system that's at the heart of the whole solution. The gateways are put in a backplane similar to this one to accommodate for the power and the room requirements. Of course, there is the usual network stuff like IP switches and that like. And the most important stuff that gets to you at the end of project like this, which is certification. The certification may seem trivial because it's mostly about the spark resistance. They put all kinds of currents through the system and see if any spark comes out. If something comes out, the system doesn't get certified, and if everything is all right on the front, the system gets certified. So it's not certified on features or anything else, because that's not up to them to decide if this feature is required or not. It's all regulated. They only certify on the spark resistance, and of course, trials. You have to go through trials, to real life situations to know if your system is up on par with the previous one or anything else that's on the market. So, not so funny fact now. That's the phone I showed you before. That's one, that's one that was gathered from coal mine shafts after a big explosion. A few coal miners, they had, the methane exploded, and there was this emergency situation. And in fact, they were heavily burned. They had they couldn't make a phone call with it, but the line was still intact, and the only thing they could do was get handle of the handset. They just put it off hook, and that's how the rescue team located them. That's an interesting fact. And in fact, this phone is on display in the Coal Mine Institute in Poland as a real case scenario documentation of how technology can save lives in coal mines. So that's the basic stuff I wanted to talk about. Of course, the basic stuff I talked about, the queues and stuff like that, it's easily implemented on the asterisk side. The hard part was integrating it all together. We did it. It works, and it's live in a few coal mines down there in Poland. We're expecting to acquire more coal mines and possibly any other kind of mines that require such systems. Any questions?
Thanks. So are those phones analog, and how did you connect them back to Asterisk? At what point did you put that equipment?
Maybe I will be going back and forth. Okay, so I was showing the slide with the gateway. It's analog gateway. Oh, no. we've built a array of gateways based on Blackfin platform and using the Syllab chips. It's an analog phone with some additional features available through DTMF signaling and FSK signaling. The keys, the additional keys here at the right side of the phone, there are specialized keys. There are special meanings depending on the call mine. For example, A may mean a flood, and the B rise to metal level and stuff like that. So it's signaled back to the. It can be signaled back manually to the central system, which is asterisk at the core of the system. Yeah. Okay. Any other questions?
I got it. Sorry, you can get it back up. The methane detectors, the radio frequency ID, the Bluetooth gateways that you were mentioning, are those also built into the phone?
Some of the stuff is built into the headgear of every miner because, for example, the Bluetooth chips, they have to be located where the miner is, so it couldn't be located at the phone. But it's all connected to the central system, which consists of asterisk. So it reports back. It's every signaling that goes there goes either by IP, which is rare because of the wiring. There is a rough area around there, so they have only a few wires down there, and most of the things are reported back by analog lines, like the RFID chips or Bluetooth gateways. They have their interfaces in the system through analog lines, and the signaling is sent either via DTMF or FSK.
All right, Alec, you do good?
I had exactly the same question.
Okay.
How do the analog signals get connected?
Yes, exactly.
So what's the cable runs? How far from the phone to the gateways?
It's complicated. The cables, the cables is quite another story. There's a specific company that's running that a few hundred meters. A few hundred meters because there are repeaters and stuff like that. So the end line is a few hundred meters at most, up to I think kilometer, not longer, because of course of the signals, and there's a lot of interference. Of course, it was a very condensed form of describing what the system is, and I didn't describe the parts that are most of the parts that are underground. I just mentioned them, but it's complicated. Yeah, and all copper wires. Nothing else works there because it's really rough down there. Anyone else? I'm happy to answer all your questions.
All right, last call.
I would not recommend going to the coal mine down there. It's very hot. The humidity is off the charts, and the noise is comparable to the constant noise is comparable to the starting engines of a big plane. So it's hard to talk there over the phone most of the time. So there are some fancy stuff done for the echo cancellation, noise cancellations, and stuff like that. It was obviously not a part of the presentation, but it's done in the phone. It's very advanced phone. It doesn't look like that, but it's very complicated piece of equipment in itself. Anyone else?
All right, so yeah, I've actually got one. And the phones, did you build the phones as well, or is there a company out there that manufactures them specifically for the mining industry?
The phone is produced by the company that started this project. So their main business is building the phones. And of course, they had to integrate it in a single system. So they had this PBX, which was custom changed, and it was off-the-shelf PBX with some custom modification they used for like 15 years. And then the shortages of components came, and the development cycles just went longer and longer. And so they looked for another solution, and that's how Asterisk fit in the whole scenario. So yes, it's and the fact is, it's not some Chinese product. It's all hand built in Poland, so it's handmade.
All right, anybody else? Okay, one last one really quick. Is the mouse pad on the side of that PC there to keep it from sparking? Is that why that's there?
Yes, it is.
Okay. All right, well, everybody, let's give Jakub a huge round of applause. I think he's done an excellent job. Thank you very much.